Again, quiz on Tuesday, page 59, 1 through 4. This announcement to those of you watching on the video. Make sure you know the midpoint formula, distance formula, and others. Midpoint formula, like I said, on page 12. Distance is on page 9. Give you about 10 more minutes. Okay, let's take a look. Number 1, on page 59, it says, point M is the midpoints between A, which is at -5, 4, and B, which is at -1, -6. So quick review of the midpoint formula. We add the x's. That's an x. We add the y's. Divide by 2. That gives us the midpoint formula. Tomorrow I'm not giving it to you on the quiz. You got to know it. Midpoint formula right there. Then let's plug it in. -5 plus -1 over 2. 4 plus -6 over 2. X's, Y's over 2. -6 over 2. -2 over 2. Should be able to do all this simple math in our head. -3, -1. Show of hands, who got the correct answer? -3, -1. Very good. All right. Number 2 is a little bit more involved. I think one of the most difficult things about number 2 is looking at it and seeing what the coordinates are. So if I look at the graph, Coy, what's the coordinate of E? 2, -1. He's right. Sorry, Andrew. I'll have to call you back. 2, -1. Every line in the grid is worth 2 to Ron, not 1. Did you catch that?
Yeah.
Did you? Don't lie.
I did.
Good. So E is 2, -1. F then would be what? 8, -1. And then G would be 8, -9. Did everyone agree with me? Okay, so then the rule, I'm going to write the rule right above it. And it says x minus 1, y plus 5. So this is what it's being mapped to. X minus 1 and y plus, well, boy, butchered that. Let's write that again. X minus 1, y plus 5. There we go. Now, let you see it. X minus 1, y plus 5. Then we draw an arrow across and we apply to get E prime. So then it's just a simple math in our head. 2, and we go minus 1. That means we end up at 1. Then -1 plus 5 means we end up at positive 4. So positive 1, positive 4. Do the same thing for F prime. 8 minus 1 is 7. -1 plus 5 is 4. Do the same thing for G prime. 8 minus 1 is 7. -9 plus 5, -4. Okay, so that looks like that's going to be about here. Kind of looks like that. Approximately. Not exactly Troxel, but approximately. Okay, so now when it says try and confirm that it's a rigid motion, meaning that it maintains distance and angle measures, don't worry about the angle measures. Tomorrow, don't worry about the angle measures. We're not going to have you get a protractor out and measure it, okay? But I do want you to confirm the distances. All right, so we can do that. So if this is E, this is F, this is G, let's find the distance from E to F between 8 and 2. So the length of EF is between 8 and 2, which is 6. Okay, now let's make sure that that's the distance between E prime and F prime, which is E prime is 1 and 7. E prime, F prime, isn't that also 6? Check it. Am I going too fast, Ashton? Okay. Caden? Good? All right, let's go to the vertical one. Let's do FG. FG, that's going from here to here because it's just a single line. So -9 to -1, how far is that? 8. So we'll go F prime to G prime. That's 4 to -4. How far is that? 8. Remember, distance can never be negative. Distance is always positive. Length is always positive. Okay, the only one that's going to require us to use the distance formula, and I'm going to come over here to the left a little bit, is the E to G, is this distance. I'm going to put a question mark there. So the distance of EG. All right, so I'm going to use asterisk, asterisk. These two coordinates, I'm going to use the distance formula. Refresher, change of x's, 8 minus 2, quantity squared. Negative 9 minus a negative 1, quantity squared. That's the distance formula. Tomorrow you got to know it. 8 minus 2 is 6. 6 squared is 36. Negative 9 minus negative 1 is negative 8. Negative 8 squared, 64. Square root of 100? 10. All right, without showing it, because I'm running out of room on my paper, EF prime is also, EG prime is also 10. So we got both. All three are then 10. Same length, 6, 6, 8, 8, and 10, 10. All right, are we good? That's all you had to do on number 2. It's kind of a lot, but we don't have to do the angle measures. All right, now let's go to number 3, number 4, dealing with angle bisector. Okay, so this is number 3. Let me get it on the screen. Now we go angle bisector. I'm going to put it as a dotted line, dotted ray. It says the ray GJ. So they don't tell me to make a picture, but I think it's helpful. Farmer, make a picture. GJ. Okay, the angle bisector of angle FGH. What's G called? I know it's a point, but what's it called of an angle? The vertex. Good, the vertex. We know that the measure of angle FGH is 75. That's given. So that means, let me use a pencil. This entire thing right there, 75 degrees. Color it in, color it in. The whole thing is 75. Well, they use the term angle. Well, I'm going to write it out. Angle bisector. What's that mean? Bisector. Bryant? Cuts it in half. That's right. So all we have to do to find the measure of angle FGJ, which is this one right here, is take half of 75. Because it's half of the whole thing. Which then is, what, 37.5? And we're done. Simple. Okay, let's do number 4. Very, very similar. Number 4 says the ray XZ, dotted line ray XZ, is the angle bisector of WXY. A picture, Tehran, is helpful, isn't it? Yeah. On the quiz tomorrow, make sure you have it. I might provide the picture, but still. Okay, now this says the entire thing is what, 155? An obtuse angle. So the measure of angle WXY is 155. They want us to find half of that, which is YXZ. So 155 over 2 is, what is that, 77.5? And we're done. Okay, I got one more I want you to do. Turn to page 58, and do number 4. This is prepping us for the quiz tomorrow. 58, number 4. Just turn to your left. It's right there. That's not us. Okay, how do we do it? Let's see. So the rule on number 4 is 3x, 2y. So we're going xy, map rule to 3x, 2y. The 3 coordinates, A is 3, 5, B is 5, 3, and C is 2, 2. All right, so then 3 times 3, 9, 5 times 2, 10. That would be A prime. B prime would be 5 times 3, which is 15. 3 times 2, which is 6. And C prime, which would be 6 and 4. Questions on how to do the mapping. That's all they wanted. Then they asked the question, is it a rigid or non-rigid? It is non-rigid. This is like a transformation, but it's not exactly a dilation because it's not equal to the x and equal to the y, but it just basically enlarges. Okay, the length of the sides would be longer. Questions? All right, before I turn you loose, here are a couple things you're going to need to know tomorrow. Not only the midpoint formula and the distance formula, not only the bisector concept, but you also are going to have to recall this. There's a segment. Here's a point on the segment. This is called the segment addition postulate. If this entire length from here to here, from there to there is 4, and the entire length is 16, then coy, what's this length? 12. I know, it's simple math. It only gets more difficult when we are putting variables in there. Like this is x plus 4. Then you've got to set up an equation of x and x plus 4 is equal to 16. Do you guys remember us doing examples like that? We had a homework assignment on it, and also we did problems. In that case, then we would solve for x. 2x is equal to 12, and then x is equal to 6. Does that make sense? We good? Okay. The exact same thing has to happen for the angle addition postulate. If this is x and this is x plus 5, let's say, and this whole thing is 29. Okay? So then we'd go x plus 5 is equal to 29. 2x is equal to 24, and x is equal to 12. Okay, so the segment addition postulate and the angle addition postulate are also possibly on the quiz. We good? Okay. All right, signing off. Quiz tomorrow.